Doing Atcoder Beginner Contest 364 today. Let's see how this goes. Alright, starting right now. Moving a little slow already. Okay. Planning to eat and dishes. The ith dish he plans to eat is sweet if Si equals sweet and salty if Si equals salty. If he eats two dishes consecutively, he'll feel sick and be able to eat any more dishes. Determine whether he can eat all the dishes. Okay. So is this just checking for two consecutive sweet dishes? Okay, that should be pretty simple. So we're given n and then a list n. So let's see. N equals int input. Oh, I have to. This is by. We're gonna name this to py. There we go. And then we're gonna get our list of snacks equals input x for x and input split. And then we'll do for I in range length of snacks minus 1. Do if snacks I equals sweet and snacks I equals 1 equals sweet, and we'll print no. Is it printing? Yeah, print no. True. I'm just using this answer to keep track down here. If answer print yes. Okay, so I think that should work. So let's take an example here, and we'll do a yes. Let's do this one. I don't know why I'm getting this output like this. Oh, I think we have to do, we can't do this, we have to do for I in range and snacks. Okay, let's try that. Hmm. Oh, that's but now I'm printing it twice. Let's break here. Right, and this should do it. No, but here, let's copy. Wait, he will feel sick, but he can eat all the dishes. Oh, so only if and I is not equal length of snacks minus one. Right, that's the case. So let's try this again. I'm glad I actually looked at that example because I would have failed. Yes. Let's take this one. Um, no, that should be yes. And I does not equal the length of snacks minus 2. Yes. And then here, this should be, no. Okay, cool. So I think this should work. Let's take this, and let's see. We'll move on to the second task here. So the grid with H rows and W columns. Ij denotes the ith row on the top. Okay. Cell ij is empty if it's a period, and it's not empty if it's a hash. Takahashi is currently at cell Si. That's according to the rules. If the ith character of X is L and the cell to the left of his current cell exists and is empty, he moves to the cell to the left. Okay. So it seems like we're just following the directions and moving to adjacent cells. Print the cell where he is after completing the series of actions. Right, so here we're given this, and we're given these directions. So we're given the height, width, we're given this, we're given each row. So this is a starting position each row. So essentially what would happen is he starts at Si is J, so he starts at, so I represents the row. The second row, first column here. So he can go up. He can't go left, he can go down, he can go right. And go up, so you have to 2, 2. Okay. That makes sense. Let's see if I pass this. Okay, got that. Okay, so this looks just basically like we need to take in the graph and we need to follow the directions, right? So let's do this. So we're going to take in for our height, width equals x for input split x, y equals same thing, right? And then, so for our grid equals this, and we'll do for I in range height, we're going to get our row equals int x for x and input split, and we'll do grid dot row. And let me just print the grid to make sure that's right. Okay. Int x comes out from control. Oh, oops. That's y. For x, x for x. Um, did I not save the file? X for x. x. As you can see, I need a lot more practice for x in input split. Okay. Command not found. Okay, so I have to also take in the directions, but this is not what I want. I want each of these to be an element in the array. X for x in input split. I think, how do we do this? Let's make this a list, and then we also just need to take in the directions. Okay. No. Let's see. Split. All right, let's. It should be already a. Let's just do. Input split. Let's try that. So how are they coming in exactly? Is it like it's coming in as like an entire string? So I just want to get in the input, convert it to a list. Okay. There we go. Okay. So now what we want to do is just follow these directions and see what we can do. So we want to then do let's see, do for D in directions. What we're going to do is direction. So I'm going to do if D equals up. So let's do our new x equals x and our new y equals y. Okay, so if y minus 1 is greater or equal to 0, or I guess greater than 0, right? Then we can do new y equals 1. We'll do elif d equals d if y plus 1 is less than height. Equal to the height. And you can do new y plus equals d equals if x minus 1 1 equal to width. We can do new x. And we'll do x equals new x, y equals new y, and then we'll, at the end, how do we want to actually print this? So we just want to print x and y. Okay, let's see how we do here. 2, 1, which is wrong. Okay. So we're at 2, 2. So let me print my x and y each time. 2, 1. Just like 2, 1, 2, 1, 1, 1, 1, 2, 2, 2. Oh, so I ended 2, 2, which is interesting. Hold on, so we go from 2, so then we just 1, 1. New x. So first I'm moving up, which is 1, 1. But I'm still at 2, 1 for some reason. Right, so I would be 2, 1. Oh, and if it's empty. Totally forgot that part. And one equals this, and this will be go to y plus 1, and then this will be lf grid y plus 1. Okay. Let's try this again. See if that. I don't think that's going to change our answer necessarily, but just another piece of logic we did not implement. 3. Let me go to here. Copy this again. We can move this down here. Okay. Nope. Get the input again. And I'll do on 3 if less than or equal to width. So this has to be less than width. So this should be y plus 1 is height. No, this should be width. And this should be height. Then we're just doing a traversal. So we're at 1, 1. So I have an answer, but it is not the right answer. Okay, so what happened here? So looks like we get stuck. We go from 2, 1 to 2, 1 to 1, 1. I'm not sure why we're at 2, 1 twice, right? So okay, so we're not even getting into that up y minus 1. Okay, so we're starting at 2, 1. So if we're going up, we're changing our x, right? So should be x minus 1, x, 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 and then x, y minus 1, y minus 1, y plus 1. Okay. Still on 1, 1. And I'm still not getting, okay, so I got into the up, I went there, and then the next instruction is left. So I wouldn't go left, but then I want to go back down, so I'm not getting into down. Okay. Okay, so I'm going down, but I'm not changing. If x plus 1 is greater than height, and this should be width. Okay, so I'm printing 1, 2, which should be 2, 2. Less than or equal to equal. Nope. Less than height. Why I did. Okay. So if x plus 1 is less than our height, we can go down, right? So equal to, nope. Okay, so for whatever reason, I'm getting here, but I'm not actually getting, I'm not going down. Why? Okay, so I'm changing my down. If x plus 1 is less than our height being 2, or rather, hold on, height and width is less than or equal to our height but that should be okay. Oh, so let's actually do height minus equals no, we'll do, oops. And then it's greater than or equal to, less than or equal to. And then at the end we'll have to do plus 1 to get the real ones. There we go. That is the right answer. Well, let's see if I can get it to work. Okay, so let me get rid of this, get rid of this, get rid of this. Alright, 2, 2. Let's try this one. 2, 4 is our expected answer. Really hope it says 2, 4. Ah, damn it. Alright, what's going on here? Equal to height, right? Because we don't want it to ever be equal to our height because that's an index. So we need to do this. 2, 4, which is what we expect. Let me try this first one again. 2, 2. And then let's try this. We should get 1, 1. Alright, they say these are beginner, but these are a little tricky, honestly. Alright, let's submit. I bet I'm going to get a wrong answer or something, but let's see. The minimum glutton. There are N dishes, and the ith dish has a sweetness of A and saltiness of B. Takahashi plans to arrange these N dishes in any order he likes and eat them in that order. He will eat the dishes in the arranged order, but he will stop as soon as the total sweetness of dishes he has eaten exceeds X, or the total saltiness exceeds Y. Okay. Still waiting. Okay, cool. Okay, so it looks like it might be, we want to find the minimum possible number of dishes, right? So maybe DP, like we want to know, these are what? What is A and B here? This is dish I. So these are the number of dishes. This is the saltiness. This is sweetness capacity, saltiness capacity. And then these are the salty sweetness, and these are the saltiness, right? So if he arranges the dishes in order 2, 3, 1, 4, as soon as he eats dishes 2 and 3, the saltiness is 8, which is greater than 7. Therefore, in this case, he will wind up eating 2 dishes, right? So basically, I guess we could sort them by both sweetness and saltiness, and whatever is less, right? So here we have, count will be 1. You cannot eat. So we want find the minimum number of dishes that he will end up eating, right? So here we have his sweetness is 7, so we can do these two. We have to sort them here, so we have 1, 2, 3, right? So I think that should be pretty simple. I mean, I say that now, but you saw how the last one went. So we're going to do our n x y equals x for x in input split, and then we'll get sweet equals same thing. Just copy and paste. And then salty equals int x. Okay, so if we sort them, let's do dot sort, and then we'll do so maybe sort them in reverse order. We can just go backwards and do so for let's do sweet equals list salty and we'll do try in range sweet. Let's do current sweet equals 0, current salty equals 0. Right, so if we get to index 2 and we can't do it anymore, that means we can just return that index, right? So num sweet equals 0, salty equals 0. Okay, so if current sweet plus sweet I is greater than x, what we can do is num sweet with I, and then we can break. And we'll do the same thing for the salty, 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 and then salty, and then I want to print the min of num salty and num sweet. Okay, let's see. Zero. Okay. Okay, so that's y. 0 again. Why is that happening? Salty, I. If current salty plus salty I is greater than x, so okay. And let's oh my god, I'm so stupid. I'm just like but I'm still getting 0 for some reason. Alright, num sweet. I need to do current. And then okay, so we can do up to this, right? Exceeds. Okay. So sweetness. So why are we not getting? So our sweetness is 5.3. Oh, the minimum number of dishes, right? So if he eats, yeah, I don't understand. So the x is 7. So if he ranges the dishes 2, 3, 1, 4, I plus 1, I plus 1. I think maybe we need to put these together. So you like zip them. Um, okay, so let's do equals zip. So let's by, I guess we can pass sorted key. Alright, so you could do this, do both, and we'll give them a lambda, and x, y, and then we'll sort here by, what's the syntax here? Key equals lambda xy, and we're going to sort by x, and then here we want to sort by y. Okay. Okay, and let's just make sure that this is in the right format. Nope. Let's see. Minimum glutton. Salty is not defined. Salty. Should I save that? I did. Missing run required argument y. Let's just do x 0 and x 1. Make it simpler. Int and tuple. Alright, so basically now what I want to do is I'm going to still do two loops, but anytime either of those values exceeds, we'll keep track of that. So we'll do sweet I0 or current salty plus sweet I1 is greater than y. We can have our answers, and then we'll do to answer I plus 1, and we'll break, right? And then we want to do the same thing for salty. It's going to be the same condition, and or current sweet plus salty I0 is greater than x. We'll do, else what we need to do is current salty plus equals 0. And let's do this. Current is salty and salty. And then we'll do answer append I plus 1. Okay, and then we're going to print the min of our answer. Let's go back, get this input again. And the list current salty. Am I making it a list somewhere? Current sweet, current salty. This is in what line? Line 19. Of int and list. What does sweet look like here? Oh, what in the fucking world? What is going on there? Jeez. Alright, some weird shit going on here. So this is a thing. Let's just do both equals. Sweet. We'll do both. Append sweet I, salty I, and just make this whole thing into a tuple. I don't know what's going on. Alright, I. Okay. How is the index out of range? They're the same length. This doesn't make any sense. All right. List for some reason. Oh. So then let's print this again after the fact to see if there's something wrong with our lambda function. Here. Okay, so here we're sorting them correctly, right? So we print our answer at the end. So maybe my algorithm is not right because, like, here we can eat 1, 2, 2, 3, right? We can eat these. Wait, this is not sorted. This is sorted, right? So we could eat 5, 3, but once we get to here, we can't do this anymore. So how is 1 not the answer? Find the minimum possible number of dishes that he will end up eating. I'm not sure why I had y there. 1 still. Okay. So we want to like maximize the number. Do we want to spread this by like the largest sum, maybe, or um, minimum number of possible dishes, right? So if we eat this 8, we can eat this, we can eat this, and we can eat this, right? So we can eat 3 of these before we get full from sweet, or we can eat this and this. We can eat 2. uh, so here what's happening is we're coming here, we're saying we can eat this, and we can eat this, but then when we get here, we are full, right? When we get to this point of our suite, we're saying we cannot eat anymore, and then we're pushing I is 2 here, so we're pushing I plus 1. Is that right? Yeah, so basically we're actually stopping at this index, and we're saying if we add this next one, we won't be able to do it. Okay. So we'd say, okay, we could eat 2 dishes. We could eat 2 sweet dishes. But no, that's not right because, wait. Actually, let's do this. So instead of this, we'll say if we're already there, right? So that would not happen until we get here. We'll say I plus 1. Okay. Does that make sense? Still getting 1, unfortunately. Okay, so the first time we're saying we could eat 3, so we can get 1, we can get 2. But that's not right, because we're here, as you can say 0, 1, greater than or. I'm curious what I is. I is 2, right? So we prioritize the salty dishes. We can eat 1. Okay. We can do. There we go. Okay, so we got 2. Let's try this example. So we'll do if answer equals not answer, or rather print. We're not returning here. Five. Okay, that's right. And then let's see. This is gonna be the hard one. If we get 6, we do. Okay. So let's just delete all our prints here. Let me just comment them out for now because I might need them again if we get a wrong answer. Cool. Let's try this. Then we'll open up our tasks. Kth nearest. There are n plus q points on a number line, where a point AI is coordinate AB. For each j, q, consider the following questions. Will x be the point that is k closest to bj? Okay. I'm not really sure what this is asking me. Alright, we'll come back to this. Let's see if we can get this one. Okay. Okay, so we're given n and the number of queries. There are n plus q points. Okay. So these are the A points, and then these are the B points. So we want to find for B1 to be -2 to BJ. I'm very confused by this. Let's try to go back here. Okay. So we got a wrong answer. So is there something wrong with our algorithm? Potentially. Right, of course, it's not going to give us what's actually wrong here. So let's try to think of a case where maybe picking picking the largest has to be optimal, right? We need to try both, and then we need to figure it out, right? So, I think if we, I think if length of answer not equal 2, let's try that. And I think that's because if we only get one, then that means that the other one we can actually eat all of? No, that doesn't make sense. Wait. No, that doesn't make sense. Because if you only get one answer, right, that means that we found a minimum. So we have to use that value. If we get 0 elements, that means that we haven't found any limit, so we can eat everything. And if we found both, we take the minimum, right? So if there's 1, that means that no. Okay, so this is not right. Length of sweets. So so salty, sweet, salty, sweet. So I'm trying to think, maybe is there a situation where we want to mix salty and sweet? I don't really think so, right? Because if we're eating the max salty ones, that guarantees that that's the minimum number of salty that we can eat. On the other hand, if we are eating just the max sweet ones, that's going to be the minimum number of sweet that we can eat. So it definitely makes the most sense to prioritize one and then the other and just check. But I'm not sure why I am not, like, what case would this happen in? I'm trying to think. Let's see with my new code if we get a different answer. I'm sure we probably will, but I don't think this is right. Copy. Um, okay, so what if we changed it so it was like, yeah. So what if we did something like this? Okay. Oh wait, this is not right because we could only eat 2 sweet, right? So we can't eat any more. So it has to be equal, equal, equal. Okay, that makes sense. Let's try this one again. So this should be 2. This should be 5. And then this should be 6. Use close Docker. I don't need this. Okay, so we're getting 5 now, which is not right. I just dumb. Okay, so now we're getting 6. Let's copy, undo. We're still getting 3. Okay, so that's definitely a case. So Okay, so we're getting 3 here, and that's not right because we can eat 2. I think something just off with like how I'm checking. Uh, think about this. So we could basically say if it's greater than x or greater than y. No, but we can. No, that's right because when it exceeds, right? So we could eat 3. We could eat 3, and we don't exceed until that point. So we're saying like when we eat 3, we can't eat anymore. So that's actually right, I think. Um, if okay, so I haven't actually changed anything. What did I submit last time? Um, so why would I be getting a wrong answer? Uh, unless this is just not the optimal way to do it, right? Um, we're sorting is not correct. Salty I plus 1, salty I 0, salty current sweet. A lot of variables going on. Maybe I'm doing something incorrectly here. I'll clean this up a bit. Right. Sweet and salty. I don't need this. That's not a thing anymore. Okay. I can't think of what case I would be failing, right? Because I'm okay. So here we're prioritizing the sweet. All right. So let's just comment prioritize sweet. So here we're always going to take the sweetest ones, and we're going to add them on. So we add onto here. We're saying we're prioritizing the sweet, adding the value here, but we're also keeping track of the salty. And if we ever get to a point where either of them exceed, are we just going to break, right? Same thing here. We're going to reset. And then we're going to iterate through the salty ones. If there's ever a point where either of those exceed, we're going to break, and then we're going to prioritize the saltiest ones, but then also add the sweet ones, right? And then if we get to the end, so there's 3 cases. Either it's completely empty, this means we can eat all of them. If there's just 1 in our answer array, that means that we want to return that, which should take care of this. So basically, the situations are if there is 0 in the array, we're just going to take all of them. If there's 1 or more, we can just take the minimum of the array. Because if there's 1, there's only 1 element that we found limits us, right? That means like we found a limit in either sweetness or saltiness, so we should just take that one. If there are 2, then we found 2 limits, we still just return the minimum one. So I feel like this should work. Maybe there's some weird thing with like integers or something. There was a contest recently I was doing where because of like float precision, I was getting wrong answers, but I don't know if that's the case here. Times 2 times 10 to the fourth. Let's see. Cannot be 1 or less, so print 2. E cannot be 1 or less. Any order he likes. Yeah, so it could be any order. Like, so there's no way there's going to be a different number of dishes or anything like that. Okay. Let's try this. I get 6. Let's try to make some test cases. So what's a test case that might fail? What if we had 1 dish, 200, and then we had 201 and 201 here. Let's have something like this. I'm assuming we would just get 0, or we get 1, which seems correct to me. Oh, what if we could eat all of them? What if we could do 99, 99? Right, what if we did this? 1 still, right? What if we had maybe this? Okay. What if we had 2? Our limit was 200, and then we did 1, 2. I'm assuming we're gonna get 1 here, right? Because we could say we could just eat this 1 dish. I'm fairly sure. Yeah. Maybe too much memory, maybe? Is that the thing? It's worth a shot. I mean, let's do, and sort it by the sweet first, and then we will sort it by the both. Both. I don't think that could really matter, but you never know. Let's see. I mean, it still works. I mean, it's worth a shot. I'm not printing anything. Let's try it out. Let's see. Less bites. I guess that's good. I don't really know. Wrong answer. Oh, God. That's even worse. What did I do wrong? Oh, God. Oh, so it says S the same. What is this? Wait, no. Is that the old one? So I got way more wrong this time. Just in sorting like that? That's pretty weird. Um, I have an example of how those are used. Whatever. So it sorts it in place, right? Alright, so I don't think that's it. It'd be nice to save some memory, but I doubt that's the issue. Okay. Hmm. Salty, current sweets. Answer. Salty. Salty. Sure, we're actually doing these in the right order. Yeah, I mean, it seems right. I just don't get why it's failing. It's got to be something like integer issue or like memory overflow. Because the logic seems pretty good to me. Keep trying to think of test cases. We're not gonna give up. Just gonna keep going. All right. So what could be failing? What could be failing? There's no way we can get like a negative number or something like that, right? Or is there? No, all greater than 1, greater than or equal to 1. Um, is it memory? Because I'm just like, I'm keeping two versions of this list, which could be it. Let me try it out. So we're going to here, we're going to both sort key equals lambda for x, and we're doing x0. So this is sorting it for sweet. This is sorting it for salty, right? So let's, after we do this, print both. And then we're also going to print both here. But we need to change all this stuff. So change both here, change both here, change both here, change both here, both here, both here. Okay, so we don't have sweet or salty anymore. Yeah, both. Okay. Oh, so let me go to that test case down here. Oh, so we're not sorting it, right? That's odd, right? Because we have to reverse it then. Both equals both equals. Okay, that makes sense. Let's try this one. 6. So we get 5. Okay, so let's comment that out. I don't think this is gonna be the difference, but like I can't imagine why this answer would be wrong. So let's just give it a try. So we have more code size. I wonder if the memory is going to be similar. I think it should be okay to do the sorting. Oh shit, that wasn't it. Okay, so I guess that goes to show you there are pretty strict memory limits. I guess it's 43 kilobytes is the, okay. I honestly don't really understand why, but there we go. So let's see maximum button. This would be a good follow-up. Period n, jukes for Snoop, this from point to n. He likes delete all the dishes in the order they are arranged, but if at any point the total food dishes eat some har, eat as many dishes as possible. So I feel like this is just the opposite, but I feel like there might be some kind of complication, right? We probably want some kind of like, okay, so n is really small, which really, this might be like some kind of DP problem here. Yeah. This is almost like like combination sum on LeetCode, where it's like we need to select elements that um, that like might be less than or equal to a certain sum and find the maximum. See this or D. I'm just trying to figure out what D is even asking me to do. There are n plus q points, AI, AN, and B1 to BQ on a number line. Okay, so we're given a set of points A and then a set of points B, where AI has coordinate AI and BI has coordinate BJ. Okay, so what does this mean? It's given the coordinates are 2 points, right? So we have 4 points N. But what does this mean? How can I, oh, it's on a number line. So it's not a coordinate plane. It's just on a number line. Okay, so then what we want to do is say, for each of the queries, let x be the starting to the point that's kth closest to bj. So find the distance between x and bj. More formally, let di be the difference. Okay, so what I'm thinking here is like we could probably use a heap for this. So like, ooh, this might be n times q time complexity. So like, we map all these out, and essentially what we do then is say, for each point B here, we want to find the kth closest point. So we get -2. We want to find the third closest point to that. What we'd have to do is iterate through every other point and basically like put them in a heap and then return it, right? But we could probably use the heap queue. Let's see. So we're given I q equals int x, where x is input x, and then what we're doing is getting all the points. Okay, so a equals x, where x is input. I don't know what I'm doing. I can tell I'm starting to lose steam. B equals int x. Right, and then what we're going to do is basically for I, so we're going to be given, so for I, range q, b, k equals int x, for x in input. Okay, so now what we want to do is say the distance between all of these. So we're going to do heap equals this, and we'll import heap q. So what we want to do is we want to have a heap of size k where we keep track of we want the kth closest, right? So the kth smallest. So what we want to do is have a max heap where we're basically always, if we ever exceed it, if basically want to have a max heap here. So what we're going to do is for p in A, I'm going to do heap q dot heap the absolute value of b minus p, but we're going to make this negative so that our heap is a max heap. And then what we're going to do is if heap q dot heap the length of the heap, we also have to pass in our heap here. So if the length of our heap is greater than k, q dot heap top heap, and then at the end, what we want to do is just print heap 0, I think. This might be totally off. Well, let's see. Inputs. Do split. -2, -13, -13. Okay, so actually we're pretty close. 7, 3, 13. So this is n times q. My concern is that this is just going to be too slow. So 0, 0. Let's see. 11, 66, 59, 54, 11, 67, 54, 88. Alright, so this like basically works. Let's give it a shot. First thing that happened. It seems like it's gonna fail. I mean, I don't know this platform that well, but the fact that it's still on one is kind of concerning. Yeah. Okay, I figured that was too easy. So I guess the problem is that for every query B, right, we need to basically iterate through every other element, every point on the number line A, which is just way too slow. So is there a way that like in constant time we can get those points, right? And we're looking for the distance, right? So we want the distance to the kth closest point. So how exactly would we do that? Well, if we have a point, say, I don't know, say we have a number line somewhere, we have like here, we have like -2, 0, 3, 7, something like this. Right, so if we say are looking for 1, like say we're gonna put a 1 here, let's do this. If you put like a 1 here, like say, all right, well, what's the kth closest point to 1? And say we want the second closest point. Well, that would either be, this is a -2, but you can't really see that. I'll do with that. So, do this. Okay, so we have this number line. We're looking for the kth closest point. So we have, let's make this 5 just to make it clear. So here, -2 would be the second closest point. Like say we're looking for the k equals 2. We want the second closest point. So 0 would be the closest, right? Because this is 1 away. -2 is 3 away, and then this is 4 away. So this is the point that would be k equals 2 closest, right? But the problem is with my solution, we have to go through all of these points every single time. So is there a way that we can like take a query and a point and then automatically know like what is the closest, right? Because we know that, so say we know like what's on the left and right. So if we were to like somehow split our number line into 2, we would know that, all right, so we're at 1. There are this number to the left of me and then this number to the right of me. Is that helpful? I am not really sure. Right, so the kth closest either has to be, for example, so it could be all the way on the left, so here, it could be all the way on the left if all these points are farther away. Or it could be all the way on the right if all these points are farther away than everything on the right, or it could be some combination. So like this is first, this is second, this is third. So let's see. How much time do I have left? I think we only have 5 minutes. All right, I think I'm going to call it here. We have 4 minutes, and I think it's very unlikely at this point that I'm going to be able to figure this out. So I hope you enjoyed watching this. Didn't do as well as I would have hoped. You know, these contests kind of sneak up on you. They're pretty tricky, but hope you enjoyed watching it. Thank you.